This is a second video on 5.3 factoring. This is 5.3.2. We're just talking some practice factoring again real quick. Solving this, I want to find two bubbles. I'm going to guess and check because the A value is 1. If the A value is 1, you should just pretty much always guess and check unless you need to do grouping or something. I know these are both going to be x's. I want two numbers that multiply to 12 and add to -8, and that's -6 and -2. -2 and -6 multiply to 12 and add to -8. So I want x minus 2 to equal 0 and x minus 6 to equal 0. So I get that x equals 2 and that x equals 6. Those are my two solutions. Factoring only works to solve if it's equal to 0. If it's not equal to 0, it's not going to work. It's because that zero product property that we talked about, where if a times b equals 0, we know that either a or b must be 0. So it only works if it's equal to 0. Well, this one I can also still guess and check, I think. And I know this has to be a 2x and this has to be an x. And the number that goes in this spot is either going to be a positive 3, a positive 2, or 6 and a 1. 6 or a 1, because these are the numbers that multiply to 6. And I can't find two numbers that are going to multiply to 6 and combine to 5. This one can't be factored. Can't be factored or can't factor. That doesn't mean it can't be solved. That just means that it can't be factored. So let me think about if I do this by grouping. If I have 0 equals 2x squared plus 5x plus 6, 2 times 6 is 12, and I want two numbers that multiply to 12 and add to 5, 12 and 1, 6 and 2, 4 and 3. Nope, this just can't factor. With grouping, it's nice because you can see all these combinations that can't add up to 5. So you just know that this can't be factored. I'll go over this third one over here. This one I can also do by guess and check pretty decently. I'll put a 2x here and an x here. And if I do a 3 here and a 1 here, and I make this one negative and this one positive. Well, now these numbers multiply to -3. No, I don't want that. I want positive 3. So that's not going to work. And that's okay. That's why you guess and check. 2x, x. Since I need to multiply to -3, these both have to be, I have to multiply to positive 3, so these both have to be negative. I know they have to be negative, but they combine to -5. Well, then if I put the 3 here and the 1 here, now these multiply to positive 3. This gives me a -2x, this gives me a -3x, and -2x minus 3x equals -5x. So what I really have now is 0 equals 2x minus 3 times x minus 1. So I want 0 to equal 2x minus 3, and I want 0 to equal x minus 1. So x equals 3 over 2, and x equals 1. A nice little trick for doing this quickly. Your solutions are always the opposite of this number divided by this number. So the opposite of -3 is 3, divided by 2 is 2, so the answer is 3 over 2, and x is 1. So you get those solutions. Okay, then I'm going to skip this one. Now I'm going to talk about special cases. We've already talked about a difference of squares. A difference of squares is when there's a subtraction sign, and this is a perfect square and this is a perfect square. You have to recognize this as soon as you see it. You gotta just look at it and see those are perfect squares. So I can take the square root of x and the square root of 100, and that's how that factors. Now if these both equal 0, then my solutions are x equals -10 and x equals 10. The reason this works is because when I FOIL, there's x squared, there's a minus 10x, there's a plus 10x, and there's a minus 100, and these middle terms cancel. -10x plus 10x is 0, so it cancels, and those are my solutions. This is not possible. Sum of squares cannot be done. Don't try to do that when there's a plus there. If I have other stuff, this is still a perfect square, and this is still a perfect square, because y to the 8th is really y to the 4th squared. It's a perfect square. So we have 4x minus 7y to the 4th, and 4x plus 7y to the 4th. Now this I'm not solving, because I didn't have it equal to anything. I can't solve it because I didn't start with an equation. There was no equal sign. I just started with an expression. So I don't actually solve that. I just factor it and I'm done. Please remember that 1 is a perfect square. 1 is a perfect square, so my solutions are -1 and 1. Okay, last thing. This is a very, very useful trick. If you remember from way back in Algebra 1, which I'm totally sure you do, if I did ax plus b squared, that becomes a squared x squared plus 2abx plus b squared. And there's a special formula to that. We can sort of calculate it really quickly. Well, the reason that's helpful is over here, this is a perfect square. This is 2 times that perfect square. Whenever that happens, I know that I have x plus 6 squared. Really, I have this. This is an incredibly important idea that we're going to use a ton. So you need to understand that x plus 6 times x plus 6 is really x plus 6 squared. And at this point to solve, I just know that x is going to be -6, but I can square root both sides and get that x plus 6 equals plus or minus 0, which just means that x equals -6. Or I could have taken my 2 bubbles and just subtracted 6 from both sides. So here, on this next one, this is x minus 1 squared. Because this is a perfect square, and this is 2 times that. Whenever that happens, you get this formula that you need to jump to, where x equals 1. This still only works if it's equal to 0. So add a 9 to both sides here. The square root of this number is 3. 3 times 2 is 6. This is x minus 3 squared. It can be plus or minus, doesn't matter. Now here, this is a perfect square, and this is a perfect square. So I'm going to assume that that works. I'm just actually going to guess and hope that it works. Then I'm going to multiply this out. If I do 2x plus 5y times 2x plus 5y, I'm going to get 4x squared at the start, which I knew I was going to get anyways. Yeah, that's not a surprise. Then I have 10xy and 10xy and 25y squared. Well, that becomes 4x squared plus 20xy plus 25y squared, which is not this. So this one doesn't actually factor that way. I gave it a shot. It's a little bit tougher when there's things on both sides. It doesn't actually factor that way, so I have to try and solve it some other way. I mean, it's not, well, first it wasn't solving at all if there was no equation. I'm just going to stop talking. This one was much shorter.